Okay, good morning everyone. So at this time, we will tackle about the one of the topic in Calculus 3, which is differential equations with separable variables. So this is actually the first order differential equation. Okay, so we will tackle on the concept on how we're going to find the general solution, particularly in this separable variables for differential equation. Okay, so we have here if q of x and p of y, so it means that this one or this q of x and q of y are functions of x and y respectively. Then, so we have here py, then we have dy over dx is equal to 2x. It implies that, okay, so we can separate these two functions. We have here integral of py dy is equal to integral of q of x dx. So the respective integral to these two functions. So we have here one example. We find the general solution of y dy over dx is equal to 2 over dx squared. So this one is very common problem, and it is the concept is very simple to follow. So this time we are going to find out how we find the solution of this given differential equation, first order differential equation. Okay, so let's begin. Okay, so we have here the solution. Okay, from that we have here dy over dx is equal to 2 over 3x squared. Okay, after that we can actually simplify that one as equivalent to, we have here y dy is equal to, let's multiply this dx to the other side, so it will become 2 over 3x squared dx. Okay, after that, because they are being separated, as being stated in here, separate na silang dua, we can now integrate both sides of this given function. So we can have integral of y dy is equal to integral of 2 over 3x squared dx. Okay, so that is how we are going to integrate the given two functions from the left and to the right hand side. Then we will now going to use the concept of the integral. Okay, so, or how we are going to integrate these both sides. So this will become we have here integral of y, that is equivalent to y to the power of 1 plus 1 over 1 plus 1. Okay, and the other side is equal to, we have here integral of, we can actually factor out the constant, that is 2/3 integral of, okay, 1 over x squared. Okay, then we have here dx. So in the other side, in the left hand side, this will become y to the power of 2 over 2 is equivalent to 2/3, okay, integral of, we have here x to the power of -2 dx. Then this will become also y squared over 2 is equal to 2/3. Integral is, we have here x to the power of -2 plus 1 over -2 plus 1 plus c. Okay, c is actually referring to a constant. Okay, then we have to simplify that one. That will become y to the power of 2 over 2 is equivalent to, here x to the power of -1, 2/3 x to the power of -1 over -1 plus c. Or to simplify it, we have here y to the power of 2 over 2 is equal to, we have here -2 over 3 x to the power of -1 plus c. Then simplifying, because we still have negative exponent, okay, we can make use of the property a to the power of -n equivalent to, we have 1 over a to the power of n. So that property that we will be using, the negative exponent. So this will become y squared over 2 is equal to -2/3 a over x, 2/3 x. Okay, so -2 over 3x, so we have negative multiply this one to the other side, so it will become y squared is equal to negative 4 over 3x plus 2c. Then the final solution, so we have here y of x is equal to the square root of negative 4 over 3x plus 2c. So this one is what we call as the general solution of this given separable variable in differential equation. This one is the first differential equation actually. Okay, so the pattern is just the same. So all you have to do is you want to use the concept of the basic property of the integral. Okay, and take note also that whenever you're going to get the integral of both equations, see to it that the two equations or the two functions must be separated before you can integrate, as given division at this portion, the separation and one. Okay, so I will give you another example so that you will be able to understand other problem also. Most specifically, if the two functions is being multiplied. Okay. Okay, so at this time we will continue with example number 2. So we have here another type of problem. Find the general solution of the quantity 1 plus x dy minus y dx is equal to 0. So, okay, so let's begin with the solution for this given two separable function. So we have here, from that we have 1 plus x. Okay, we have here dy is equal to, actually we can transpose this one to the other side so that it will become y dx. Okay, so as we can see, we cannot yet integrate this one directly because even though that they are being separated, but this one y, but the derivative is not in terms of dx. It should be dy, no? Dapat kauban si dy o si y. Another one, 1 plus x and dx. So all we have to do is we can multiply the other side by 1 over y, or we can multiply both sides by y, 1 over 1 plus x over times y, no? So we can have, or we can multiply 1 over x plus 1, okay, times 1 over y, okay, this function. So we have here 1 plus x, okay, dy. Another one is we have here equivalent to the same function. So we have here our quantity 1 over x plus 1, okay, times 1 over y. Okay, we have here, this one is y. Then we have here dx. Okay, then simplify. This will become cancelled out. The remaining is 1 times 1 over y. The y is 1. Okay, 1 over y dy is equivalent to what? This will be cancelled out. So the remaining is 1 over x plus 1, okay, dx. Okay? At this time, we can now integrate. Hindi na ito ma-integrate na ito both sides. We have here integral of 1 over y dy is equal to integral of 1 over x plus 1 dx. Okay? Then we can now simplify this one. Actually, the integral for 1 over y is just equivalent to ln of y. Okay, is equal to the integral of 1 over x plus 1 is actually, we have here ln of, we have here x plus 1. X plus 1 or 1 plus x are just the same. So we have x plus 1, okay, plus c. But remember, our goal is to find y of x, meaning the general solution. So to find the y of x, this is just equivalent to, okay, y of x is equal to e to the power of, we have here the whole function to the right hand side. So we have here ln of x plus 1, okay, plus c. So this one is our, okay, is our general solution. Okay? So I hope you understand very well the concept particularly in finding the general solution of in a differential equation or first differential equations, no? First parable differential equation.